Welcome to the stream for today. And the terminal is set to the wrong thing once again because of bugs. But while I'm fixing that, as I said, welcome to the stream. This is a continuation of yesterday's stream. That's not the one. It's not that one. Off to a great start, aren't we? Why are we doing this? That is really bizarre. Terminal 1, track cam 0. Do I cheat? I might have to cheat. Alright, anyway, welcome to the stream. Continuation of yesterday's stream. What did we do? We had a light kit that didn't work. It didn't work because of a very specific bug I had, where I was feeding in an integer. I was feeding in a float where we could only take an integer. I'd completely forgotten that the MicroPython implementation is a bit more, how do I say, precise in what it expects. So I'm just going to swap this over. So yes, and then if we do make watch in this window, no one will notice what I'm doing. Perfect. Yeah, code didn't work, nothing lit up. Real absolute pain. It was a real shame because off stream I had it fixed in about 5 minutes. I do want to show you what that looks like. So it's not going to be exactly the same code, but let's just plug it in just to show that it actually does work. So board from yesterday. LEDs in a bag. You'll see why I've got the LEDs in a bag in a moment when the camera blows out in terms of its color space. Basically, I didn't realize how bright these LEDs are. So it's blue, it's now cyan, now it goes to green. I'm going to call that yellowish, white, reddish. That's more whitish. Basically, it's changing colors. So what happens is it picks a random color. It works out how many steps are between the current color and that color, and then starts changing the color, I think, every 10 or 100 milliseconds or something silly like that. Very stupid proof of concept, kind of nice. Not the colored lights moving through the bar like I had in the original code yesterday, but that's what we're going to do on stream while I'm talking about this in the final product. And speaking of the final product, I want to just introduce one little thing that I picked up just recently. Let me turn the LEDs off first, because they screw around the lighting. They're just so unbelievably bright, even on the lowest setting. So you may or may not know of this product. Nintendo just had a big announcement of a bunch of products, so you might have missed this one, but
Lego Mario time!
this is Lego Mario, a little barcode scanner in the bottom. You put them on different surfaces and he detects the color and he detects your movements, basically. But what I thought interesting was that they'd taken a physical product like this and then turned it into a game. So he's Bluetooth enabled, can talk to your phone. You don't need your phone, and to be honest, the phone doesn't actually add a lot of value, apart from stealing all your information, the usual type of stuff. Let's put him on some red. Yeah, so he thinks he's on fire when he's on red. But it was great. Like, I played with this only probably about 10-15 minutes, but if I was a kid, actually if I put it on green, so you can hear the sounds different, he thinks he's on grass. Basically, they've managed to turn a physical product into a game, and I kind of liked that. Now, I don't want to turn Mini Zeds into a game. You could if you want, but that's not my goal. But one of the games I did recently play was the official game for the Dakar Rally. I'm just going to turn Mario off in the meantime. And for those who don't know, with the Dakar Rally, there's a whole lot of waypoints, and you're given headings and distance, and you basically have to make your way to every single waypoint. And if you miss a waypoint, you lose points. So you've got a co-pilot, and they'll give you pace notes, just like on like a rally driver, and you have to drive from A to B in the right direction, on the right bearing, And then when you think you hit the point, you make the turn to the next place. Now, the notes aren't just bearings and distances; they also have some landmarks to help guide you. But I kind of realized that with this board, if there's an accelerometer and a magnetometer on board, which is effectively a compass, perhaps even a gyroscope would help. I wouldn't mind having it be highly accurate. And you could even chuck GPS in the mix. What you could do is on startup, generate a whole bunch of random points within, say, 10, 20 meters of yourself. Select them the order they have to be visited in random, and then have a microphone on board that gives you the bearing and direction. So you turn up to a flat field, press start game, and then it starts reading off these pace notes, and you just have to basically do exactly like you would in the Dakar Rally. So you take off at a particular bearing, you go for X amount of distance. Once you hit that distance, you go and make the next turn. Now, we'd be able to turn up the difficulty by making the driver keep track of the actual distance, or giving you a less and less accurate distance measurement. So in the most extreme mode, he'd just give you the bearing, the distance, and not actually tell you when you're getting close to your next turn, which could be interesting. So that's sort of where I'm heading. It sounds like a very, very basic idea for a game, but I've got quite a few refinements on top of that. That's just the core of it. I've been playing a bit with some storytelling AI and some map design AI that could also be thrown on board. So stealing some of the mapping technology from Left 4 Dead and some of the storytelling from Bastion, so that as you're making mistakes and you're driving, or you're putting the car sideways too often in the turns, the AIs on board detect that and sort of weave that into a coherent story about the race itself. So if you're sideways a lot, you may have a driver, you may have a co-pilot on board that says, "Hey, look, you're going a bit you're sideways too much. Like, straighten up a bit." Or at the end, it takes all the facets of your trip, puts them together, and does a breakdown of the trip. So it's like you did well in the beginning, you're a bit loose in the middle, at the end you're probably a bit too slow and you need to speed up, that type of thing. So a lot of possibilities there. I don't know if it's for everyone, but it's the start of some interesting technology. There's no reason this couldn't be applied to drift and effectively become a coach for drifting. Or even on the racing type side of things, it's like you'd be able to push a button, get a random race course, and well, I suppose that's a bit difficult because you actually do need to see the race course in that, but I'm sure we can work something out in that regard. Anyway, back to programming. So we're now 7 minutes in, and I want to keep this kind of short, which is unusual for my videos. I mean, anyone who's familiar with my videos knows that 2 hours is not unheard of, or uncommon. So let's plug this in first. This USB port's a bit finicky. Now, I did have a question about, will this run on 2S LiPo? The answer is, I eventually want this to run on 3S LiPo. Currently, it only runs on 5 volts. But this is just a test board. For anyone who's actually looked up the price, these boards are hideously expensive, but there's significantly cheaper boards available on the market now. So I will be manufacturing this for cheaper boards and retaining the Wi-Fi and Bluetooth capability. I don't like the current state of the art in terms of setup for both drones, funnily enough, and RC cars, with complicated controller movements and everything. I've normally got a phone on me, why can't I just connect to the device and tweak it? I'd also like it to do Mini-Z ICS programming. Not everyone wants to bring around a laptop with them just to tune their car. It'd be nice to hit the web server on the car and select all the parameters on the web page, and then when your car starts up, they automatically get dumped to the car. And you could even have profiles or whatever. You may actually question why I even got into this, and that's because for the rally truck, where did I put the rally truck? I had it here a moment ago, which is kind of crazy. Anyway, with the rally truck, we're doing active suspension. Oh, there it is. Is that it? Yeah, that is. Okay. We're doing active suspension. So what this will mean is there will be a servo on each strut tower on the suspension, and the servos will be able to raise and lower the car. So the car will be able to go from like that, I think, to almost flat. Now, rally trucks are pretty heavy, so being able to go down on flatter terrain will mean less rollover, and I can go into the turns faster. But it will also allow me to tune the suspension in a way that makes it bounce a bit and make it act a bit more like a real car. And in fact, if I pull up YouTube, it's going to be so slow. Servo suspension RC car. There is actually a guy who just did it recently. So the super scale active suspension. I'm not going to play too much of this video. Do a search and view his channel if you want it, but you'll see the car is actually tilting and balancing the turns and stuff. So that uses servos on all the strut towers, and I'll be doing something similar, and this board will actually be driving it and raising and lowering as required. And one of the reasons why I want to do this is I've only got, with the NB4, 8 channels max on the RC unit, and this allows me to use less channels effectively. So rather than driving all 4 servo channels directly, I can just have like height and tilt, and then use this to map that to 4 individual servo channels. So I go from only needing 2 channel, so I can go from having to need 4 channels for the servo to 2 channels on the RC unit, which means I can then do front steering, rear steering, motor, winch, there's 4 channels already. Then I want 2 channels for controlling the lights, and then I want another 2 channels for the active servo suspension. And some features may only be available via Wi-Fi. Probably the stuff that I don't care about. But I'm getting distracted once again, and I have been known to both do that and be very, very good at getting distracted. So let's show off 1 or 2 things. So I've got a new make terminal feature. And if I hit Control C, the lights will stop. If I hit it properly, there we go. And then I get an interactive Python shell. Now I'm just going to quickly bring up the code in another window. You won't be able to see this, but I need it for reference. Main, what do I want? Colors to bits. No, I want to update pixels. Red. Now keep an eye here for when I hit enter. So you can see it's actually very, very dim. This is actually the dimmest setting it goes. So I'll take it out of the box, or the bag. There we go. So that's the dimmest setting. And I can assure you in real life it's actually brighter than it appears on camera. So let's set it to blue. And then finally green. So you can see my code works. One of the problems is each channel of red, green, and blue is just intensity. And what that means is that when I was doing my random color walk, so picking color and then swapping to it, some of them were brighter than others, when what I should be doing is picking colors and jumping between the colors, and then having the intensity of those colors at a particular brightness. At max brightness, this unit actually gets extremely hot. One of the other interesting things with this, and let me grab, I'll grab the new, so I picked up a new Mini Z Jimny case. I actually did want the blue on launch, and this is actually a blue metallic, which I didn't realize. It doesn't come out very well in the pictures, but it's very, very nice. So I had the yellow before, but this light bar fits almost perfectly on top. So I just need to 3D print a housing, and right off the bat, like the light bar stuff has already been solved for me, which is awesome. Then I can put them behind the headlights, and I've got individual LEDs here, which is this strip in a little breakout board. So I snap these off, solder the wires, and then I put one behind here, one behind there. I can even do the indicators on the side, like hot glue them on the inside there, so it comes to there, and a light there as well as the body frame. And then that's 1, 2, 3, 4, 5, 6, 7, and then the frame. And you'll have to excuse the frame, I'm halfway through modifying it. I've got another 2 lights here for the brake lights, and then 2, I don't know what they're called, like running lights or something. So that's 4 there. And then normally there's one on the front there with fog lights on the bottom. So that's 6. 6 lights in total, plus 6, 7. I should be able to math. 14. No, 13 lights in total. Now, like the standard Mini Z doesn't have the ability to run that, but it's very, very simple to do once you've got a microcontroller on board. And every single one of those can be a different color. And they can be a different color every single second. And we haven't even gone into exhaust backlights. So, okay, what are we going to do now? I actually wanted to reintroduce my original code. So we're going to just dump out of here. If I hit Control D, that will go back, as you can see, soft reboot, back to the original code. But what I'm going to do is kill that off. We're going to go back to red, which is update pixels, red, just because I don't want this to overheat and get silly hot. Let's exit out of that. Source. In the future, I'll have a much better way to program light sequences, but I've been playing with a couple of ways to do it. Funnily enough, the way you drive the light sequencing is going to be very, very similar to how I end up driving the servos as well. Especially the hardware trick I'm using to drive all 8 servos, I'll probably be doing something very, very similar, just to keep the CPU requirements down. Like this is a 200 megahertz chip, but the chip I'm actually eyeballing is only 50 megahertz, and I would actually like to get under 20 megahertz if I can, either via downclocking or something like that, just to save a bit of power. But I mean, the rally truck's going to have a fairly large, I think 1 amp hour battery on it, which for a Mini Z is insanely large, but I want to be able to run this on the smaller units as well. And I should really shut up and just do some coding. So please excuse me, I am prone to fits of insanity. We've got a reset. Yeah, so this is a code. We choose a random color, blah, blah, blah. We've got a color vector. Let's ignore all of that. Oh yeah, I've got the automatic. So I wrote a really, really nice function that every time I save this file, it automatically gets loaded onto the chip, and then I just have to restart the chip to pick it up, which has made working with this chip absolutely brilliant. Okay, what are we going to do? I'm just going to bring up the code here. Actually, let's open read-only mode. Update pixels, red. We're going to set an initial color. And then what we're going to do is we're going to have a color loop. Now we've got how many LEDs? 8. I should have been able to answer that quicker, but that's fine. So we're going to have green. Well, actually, you know what? I'm going to cheat. Green times 4 plus blue times 2 plus red. Now, I hope this makes sense to any non-programmers. Basically, we've got 4 green lights followed by 2 blue lights followed by red lights, and we're just going to have them cycle through and have like a nice bar effect. Hence why I've got color loop. So how quickly are we going to transition? While true. So this is an infinite loop, sleep. We're just going to do 0.2 and then I'll tweak it later. I could have the LEDs fade in and out and have the colors blend as they transition, make it smoother, but that's a bit more complex and I really don't want to worry about that at this point. I'd just rather get movement working first and then worry about making the color transition more gradual. When I don't have a filter over the top and they're actually individual units, and so you can see the small red dot there. Actually, while I've got this, having a small little red dot means that if you try and do any nice fancy blending characters, it doesn't work really well. You really have to fit like a diffuser over the front, or I actually found a post-it note. Like that works a lot better. Once you diffuse it like that, any blending effects you do look a lot better. And I'm going to show you why. So make terminal, color, update pixel, We're really getting off topic, aren't we? So I want you to watch really, really closely and watch as the red LED shifts slightly in position. So it moved down, and that's because this is not 3 LEDs on top of each other, but 3 LEDs in different physical positions. So each one of these is actually 3 separate LEDs, and they're not all over the top of each other. Let me see if I can... God, I'm really having to work for this one. C is equal to colors to bits. And we're going to go 3, 3, 3, so we can see all of the colors, and then we do update pixels to C. Oh, okay. That's annoying. That's actually pretty annoying. The camera's blurring them all together. No, that's actually exposure. Did I want exposure? Yeah, I wanted exposure. White balance, focus is what I wanted. And then if I do... Nope, you're not going to be able to see them. Basically, when you're looking at it in person, I can see blue at the top, then a red, and then a green, and they're all slightly next to each other. So on camera, that looks like white. To me, that looks like 3 separate colors. Okay, that's disappointing. But once you put a filter over the top of it, like this bag, which is why I had it there earlier, or even better yet, the post-it note, it blends everything together a bit and makes it in person look a bit better. Okay, so back to what we're doing. Stop and think, Jay. Stop and think. I mean, Blitz. Yeah, I shouldn't be revealing any personal information, but we'll just go with that name drop. Red, green, blue. So we're going to rotate the color loop. Color loop with the same code we used yesterday. So we take everything after the second element and shift it forward, and then add the first element, or the zeroth element if you're a programmer, to the end. So we take, wait, am I doing this right? Yeah, we take the light at the front and we move it to the back. And we keep on doing that every loop. And because we do that, the light should shift. And they'll either go left or right, and I can't remember which way it's going to be, but we'll be able to change that just by reversing the logic here. So, color loop, and I had to be really careful about this. There we go. And then we do, I'm probably going to have to do the update pixels. Actually, you know what? I'm just going to extend. I'm going to steal this code. Now, I did find something interesting yesterday. If I did, and in fact, let's go off and make a mistake. For I in range 8, so this loops 8 times. SPI send color loop. I suspect my code was slow enough that I was hitting the SPI reset and only one LED was actually updating. Yep, okay. Oh, actually, I don't even need for color in color loop. Then I can change color loop and not have to worry about how long it is. Send color. Yeah, okay, that's simpler. That's a refactor. I simplified the logic, but unfortunately to a non-program, that's not going to make a lot of sense. I really don't want to get into an introduction to programming. I can definitely explain why I'm doing something, or how I'm doing something, but I don't want to get into the basics of how programming works. And I just realized my camera's out of focus. So let's quickly view for Linux 2U. There we go. 1, 2, and for those that don't know, I've got access to all the settings on my webcam here. So if I just click focus, and the camera focuses. So this is how I change my contrast. Dynamically, power line frequency. I know what all of these do. Oh, actually this is new, LED mode. On. Blink. Oh, it's flashing. Oh, that's awesome. Okay, I shouldn't play with this on stream, but that was actually rather cool. So let me just move that out of the way. So I can change exposure, zoom, focus settings. Being able to change focus like that is absolutely brilliant. Under Windows, you can't do that. Under Linux, multiple devices can access the same video camera at a time, so it's very, very easy to do something like that. And for those that don't know, I'm using, what you're seeing in front of you is actually Linux. It's not Windows or Mac OS X or anything like that. It's my day-to-day operating system, and I've got 10 years of experience on it, so it's easiest for me to use this. So while true, send color, send the reset, rotate the color, then sleep. Let's do make terminal and exit. Okay. So you'll notice only the bottom 2 LEDs are actually switching, so likely my code is too slow. And the reset is happening at this second LED, and then the sequence is starting over again. So we've got a bug. I know how to fix this. Let's get back to the code. Oh, actually, why don't I just do that? That's silly. Nano source. Main. That makes things a lot simpler, actually. Update pixels. So the problem is this looping, and the SPI send stuff is just too slow to do it color by color. I have to do all the colors simultaneously. So that's going to be a byte array. Array. Can I just do a join? Please tell me I can just do a join. Oh, thank God. We're going to do colors is equal to sorry, I have to check the documentation on that. I don't really trust myself to remember that from memory. Iterable of bits. Okay, so that's what I have to do. Yeah. Byte array dot join color loop. This is not the best code, but I just want my code to work rather than it to be fancy, I guess. And then what I want to do is, why did I do that? Okay, I accidentally told it to reformat my code, and that doesn't work on code. It only works on normal text. That was very, very stupid of me. I normally turn that feature off, but that's fine. Make terminal. Oh, okay, that's fine, because I've got one here. Okay. And now I'm going to show you something. My code's obviously wrong. And so if we go Control C and then Control D, see how it flashes like that? Yesterday when I was trying to do the reset, it was doing the same thing. And I thought that was part of normal boot up sequence, and then there'd be another flash if my code was wrong. This is just telling me my code's just flat out wrong. So let's go back here. I'm gonna leave this IPython session open, I think. Oh no, I'm using Python Oh, that's wrong. Can I do IPython? No, okay. B, okay. A is equal B, and then we do a.join. Okay, I can do that. So I can drop the byte array in that case and just go B that. And color loop is green. And we're going to print, this is some very, very basic debugging. I just want to make sure that all the data in that list is exactly what I'm expecting. So let's exit out of that. And I'm going to watch the codes when I do the reset. And as you can see, I've got a line here, byte array has no object join. So this is another one of those differences between Python and CPython on the PC and MicroPython. So how am I going to do this? Oh, we do the stupid thing. Buffer is equal to B for color in color, no, color loop, buff equal to color. So we set an empty string and then we add, or an empty byte array, and then we just add the different color byte arrays to the end. So we've got one nice long string, and then we send that all in one go with the SPI send. And that should fix our bug. Code is downloaded. And we watch, actually I'll hold it up. We watch for flashing colors. So we've got a code error here. I thought I got rid of the join. Oh, wait a minute. Make expected indentation on line 66. Okay, so my code hasn't been downloading. It's because I've got an extra line there. Okay, so my code is on the chip. So I've actually got another window in the background that's doing the transfer that you can't see, and it's also doing some basic syntax insanity checking. So you can see here that I had an indentation error. And then if I go back to my other window, my text editor, if I just save the file, you'll see it automatically copies it to the actual flash device. So every time I save the file, it just updates it, which makes this a very, very nice experience. So there we go. And if we have a look at that, the LEDs are moving as expected. So this is what the original code was supposed to do. So I'm glad we finally have that working. Kind of nice. So this really shows the power of being able to do interactive debugging on the MicroPython board. Even when I do expose this via web interface, there will be an interactive terminal so that you can debug this. And you will be able to drop your own code on there and actually extend the light controller. So if you don't want to use what's built in to define the light sequences, you'll be able to actually write Python code and extend it that way as well. And it's not going to be locked down in any way, but you'll be able to do simple things like this, and I'll provide a holiday helpers to do different animations. I wonder if I've got that board. So I do have the larger animated board, and you could even write like small PNG or bitmap files to this, or even small movies to this if you had like a GIF or a GIF file. And it's very, very easy for me to write wrappers for that, so I'll be doing that down the track. So where are we at? We're at 34 minutes now, so I'm going to end up the stream. I do see that someone just joined the stream, and thanks for joining, but unfortunately I'm just about to end the stream. I'll probably be doing some more of these. The next thing on the cards is actually DIZV2 versus the GLD drifting sessions. That'll be happening tomorrow. I've got a 20k bike ride in the morning, and then I'll be doing, I don't know if I'll be doing a live drifting session or if I'll just be doing a review and uploading that. So we'll see on that. And then, who knows, we might even do some more programming on this, although I'm trying to make sure I don't upload too many videos too quickly. So thanks for joining me. Keep on building. I'm hoping I'm giving everyone ideas. I've seen some interesting comments and had a lot of great feedback, so that's been awesome. And I will join you all in the next session. See you later.